Welcome to our today's lesson. This is Jennifer, a chemistry official, where we make chemistry friendly for you as a learner. Today I want us to go through the writing of chemical formulae, and we'll be involving different valences. So let us begin with an element with the valence 1 combining with another element with the valence 1 as well. So we have sodium combining with chlorine. Sodium is in group 1 with atomic number 11, 2.8.1. Chlorine, atomic number 17, 2.8.7. This one is required to lose 1, so valency is 1. This one is required to gain 1, so again valency is 1. Then from there we write the chemical symbols. So sodium has that symbol Na. We write the valency on top. Chlorine, again valence 1 on top, and then they'll be exchanging the valences. So sodium takes the 1 from chlorine, while chlorine takes the 1 from sodium. And then we cancel the ones. Now that whether the 1 is there or not, there is still sodium, which is 1, chlorine, which is still 1. So the formula becomes NaCl. That is the formula. From there, we go to another element with the valency 1 with another element with the valency 2. In this case, we can involve potassium combining with oxygen. Potassium is atomic number 19, 2.8.8.1, while oxygen is atomic number 8 with the 2.8.6. So potassium as a metal is required to lose 1, while oxygen as a non-metal is required to gain 2. So this one has valence 1, this one has valence 2. So then we write the symbol for potassium, writing the valency for potassium on top. Then we have the valency for oxygen at the top, and then they exchange. So potassium gets the 2 from oxygen, while the oxygen gets the 1 from potassium. So the final formula becomes K2O after we have ignored the 1 which is for oxygen. So I hope you can see. Next we have an element with valency 3 combining with another element with valency 2. So in this case, we involve aluminium plus oxygen. So aluminium is atomic number 13, 2.8.3, and so it is required to lose the 3, so valence becomes 3. Oxygen on the other side as well, we get the atomic number 8, 2.6 is the electronic arrangement. As a non-metal, it is required to gain 2, so valence becomes 2. Then we write the formula for aluminium, and we are not supposed to have them attached to one another, so we get a safe space. So aluminium with the valence 3, oxygen with the valence 2, then we have the valences exchanging. Then aluminium takes the 2 that was from oxygen, and this oxygen gets the 3 that was from aluminium. There will be no cancelling out now that the numbers cannot cancel out. From there, we get other 2 elements, one with the valence 2 and another one with the valence 2. And by now, I hope you have realized that whenever we are writing the chemical formula, the metallic element is always on the left hand side as usual, and the non-metal is on the right hand side. So in this case, valence 2, we use calcium again plus oxygen. So calcium is atomic number 20, 2.8.8.2. As a metal, it uses the 2, so it acquires valence 2. Oxygen, atomic number 8, 2.6, required to gain 2, so again it has valency of 2. We begin with calcium. We write the formula and the valency on top. Oxygen, we also write the valency on top, and then we have them exchanging. So calcium gets the 2 from oxygen, where oxygen gets the 2 from calcium. These ones can cancel out by 2 by 2, 1. Then we go to calcium 1, oxygen 1, and then we ignore the ones. So calcium gets that formula, and it is again very correct. Here we go to radicals. So first of all, we get an element with valence 1 and a radical with valence 1. So we can use lithium with atomic number 3, 2.1. So as a metal, it uses the 1, so valency becomes 1. A radical with a valency of 1, which has a charge of that is negative. So again, the radicals that we write on the left hand side are those radicals that has a negative charge on top, just like the non-metals have a negative charge and written on the right hand side. So the radical in this case will be the OH, that is the hydroxide ion. Now that it has a negative charge, it is to mean that because the negative charge is just 1, it also has a valency of 1. So for radicals, we don't write the electronic arrangement to determine the valencies. We just look at the charge on top here. If it is just 1 negative, then the valency is 1. So then we go to the writing of the formula. Lithium with valence 1, hydroxide with again a valency of 1. We exchange the valencies, so lithium gets the 1 from the OH and the OH gets the 1 from lithium. Again, you cancel out the 1, so lithium hydroxide has that formula. Then from there we got to an element with valency of 2 and a radical with valency of 2 as well. So in this case we use magnesium, atomic number 12, 2.8.2. So required to lose 2, so valency becomes 2. A radical with the valency 2 is like the sulfate ion. This is the formula of that radical. So now that it has a 2 there, valency becomes 2. So valency becomes 2. So we write the formula. Magnesium, I already told you that you should have sharp corners up here, not rounded corners. Like we should not write the M like that. That is a small m, however big. So Mg, we write the valency on top, and then sulfate, we again write the valency on top, and then we have them exchanging, and we usually don't indicate the charge. So even though our KLB has the charges here, you should check and correct. So because the valencies are chargeless, no charge should be written on the valency. So but for where we have the formula, the charge should be there. Where we have the formula for the ion, the charge should be there. But now here, because it is a valency that you are writing, no charge should be indicated. So we have them exchanging. So magnesium takes the 2 from the sulfate, while the sulfate takes the 2 that was for magnesium. Though we have a 4 here and a 2 there, these 2 cannot cancel out because this 4 was on for the formula of the sulfate ion. So we cannot interfere with the 4. Now that in case we cancel out this 4, we will damage or will destroy the formula for the sulfate ion. So we can only cancel out these 2 and these other 2. So we end up with Mg with 1, and remember we should have a safe distance between the letters. So 1, this 1, then the sulfate with the 1, and then we cancel out the 1, so it becomes MgSO4. That is the formula. Finally, I need to show you the last one, where we have an element with the valency of 3 and a radical with the valency of 2. So we write the element aluminium, atomic number 13, 2.8.3, required to lose 3, so valency becomes 3. A radical with valency 2 is like the sulfite ion, the SO3, 2 negative, again with the valency 2. So from there we have the formula for aluminium with the valency 3 on top, SO3 with the valency 2 on top there. So I want to show you something about the introduction of the brackets. So aluminium takes the 2 from the sulfite, and the sulfite takes not the 4 but the 3, because in case we put a 4 it will be the sulfate, but you are dealing with the sulfite. So, and then there was the 3 that was for magnesium. It will also be introduced there. So I want you to get something. You see this SO3, it is the same here, SO3. This 3 is this 3 that was from magnesium. So we cannot again cancel these 3. Again, the 3 and the 2 cannot cancel. So what we do, we introduce a bracket. SO3 and a 3, we introduce a bracket. So this becomes aluminium sulfite. So I want to give you an assignment. You try the writing of the formula for a compound that is formed between an element with the valency 3, aluminium, and a radical with the valency 1, that is the hydroxide ion, aluminium and hydroxide. Again, try magnesium combining with carbonate ion. And finally, try combining calcium with a chloride. And not forgetting that there is another one before we wind up that I also want to show you. So make sure that you try those ones that I have just said, and it will be good for you for your own revision. Finally, I want us to look at a radical with the valency of 1 and another radical with the valency of 2. This radical with the valency 1 that is to be written on the left hand side like metals is that one that we call the ammonium ion, with this formula NH4 positive, meaning it has valency 1. A radical with the valency 2 is one like the carbonate ion, formula CO3 2 negative. So the reason as to why we have the ammonium ion written on the left hand side is because with the positive ion it behaves like metals. So written on the left hand side of the formula. So we write the formulas. This has valence 1, CO3 has valency of 2. So this one has valency of 2. So they exchange, and NH4 gets the 2 from the carbonate, and the carbonate gets the 1 from the ammonia. So from there we introduce the bracket as we ignore the 1. So we introduce a bracket there. Again, they cannot cancel out. They really cannot cancel out. So again, in your own free time, try writing the formula for ammonium sulfate, and again ammonium hydroxide. And as you continue doing your own revision, make more practice. Practice makes perfect. I'm wishing you the very best, and let us please continue revising. Let us continue assisting one another. To the new subscribers, feel much welcome. To the returning subscribers, thank you very much for considering this space as a part of your own time. And as we continue revising, please share, like, and comment. Let me know which other topic you would wish us to go through. So thank you very much. May you have a safe time. Thank you.